Hi, welcome to lesson number 2, module 2 of the Apache Spark and Scala course. So in this particular lesson, we will be getting started with Scala. So we will see how to work with Scala and understand some very common operations in the Scala language. Now before we proceed with the lesson, let's have a quick recap of the last lesson. So in the last lesson, we have learned about a brief history of Scala and why Scala is so special, the job trends, why someone should learn Scala, and the users and framework which are built using Scala. So in this particular lesson, we will be learning how to install Scala, the different data types, variables, lazy values, and control structures in Scala. Now, in order to install Scala, open your terminal and type sudo apt-get install Scala. Now, this command is very specific to the Ubuntu operating system, which is by default available in the virtual machine. Now, if you are using any other operating system, such as Windows, you can always visit the Scala official website and download the installer and install it just like you are installing any other typical software. Now, since Scala is a compiled language, we need an IDE or an integrated development environment to create Scala programs. So there are two popular IDEs for Scala. One is the IntelliJ IDEA and the second one is the Eclipse. Now it is up to you to decide which one to go about. Now if you are a person who is very much familiar with the Eclipse platform, then probably you can use the Scala IDE which is based on Eclipse. Or on the other hand, if you are familiar with IntelliJ, then you might choose the IntelliJ. Please note that we are using the Scala REPL or the terminal for our entire course. Now Scala, even though it is a compiled language, can be accessed from a terminal. Now the terminal is called a REPL, which stands for Read, Evaluate, Print Loop. Now from your virtual machine, if you type Scala, you can see that a shell will open where you will have a Scala prompt. This may look like a typical interpreter shell, but it is not. Whatever you type here will be compiled and then the results will be shown on the screen. So Scala REPL is the easiest way to get started with Scala, since most of the operations can be achieved using the command line. Slide. Now in order to get started with the Scala, let's try our Hello World program. So open the Scala prompt by typing Scala and then just type println in brackets in double quotes, hello, welcome to SkillSpeed. If you press return or enter, you can see that the same string will be displayed there. And Scala scripts can also be written using any text editor. So you can open up any text editor and type the same command println hello welcome to SkillSpeed and save it as a text file with a .scala extension. Now this will act as a Scala script. If you have already saved your script, and in this example I'm using the script called hello.scala, you can execute in two ways. Now the first way will be to type hello.scala from the Scala prompt. Now when you type hello.scala, then the respective output will be displayed as you can see on the screen. You can also type Scala -i hello.scala. This will open the REPL and print the output as well. Now after this, let's try to experiment with Scala. You can simply type something like 10 plus 30, and if you hit return, you can easily see that Scala will automatically calculate the result and show you which is number 40. But there are some interesting points that you have to note down from this particular example. First of all, in the result, you can see something called RES0. This is the automatically generated system variable, which means result 0. And as you can see, Scala has automatically assigned a variable of type integer for your result, and the result is 40 here. So this is the type inference of Scala. Whenever you are typing something, Scala will automatically infer the data type. Now, when you want to learn about the different data types in Scala, it may not be much of an effort because Scala supports almost all the regular data types which you are familiar in other programming languages. So the data types which are supported are Boolean, byte, short, char, integer, long, float, double, and string. In order to get a feel of the type inference of Scala, you can try typing these things in the command prompt. As you can see, when I type something in double quotes, such as hello skill speed, Scala automatically identifies it as string. A number such as 20 is assigned as integer, wherein 6.5 is categorized as double. And when you say in double quotes 2 plus double quotes 6, the concatenation will happen of two strings and the results will be 26 and not an integer. And when you do the same thing for words or letters, you can see that skill plus speed prints skill speed. Now, when you do the same for individual integers without the double quote, you can see that the result is an integer. For example, 2 plus 6 results in integer 8. Now you can even do the same concatenation with string and integer. So here is an example wherein I am adding hello and 9 to produce hello 9. Now the next topic that we have to understand is how Scala treats variables. Now variables are simply names used to refer to some location in memory, and we are already aware of what is a variable. Now in Scala, you can have two types of variables. You can either have a mutable variable or an immutable variable. So when I say a mutable variable, this means the value to this variable can be reassigned. Now you define a mutable variable with a keyword called var or var. Now as you can see from the example, I am creating a variable called test by typing var test equals to 10. Now Scala infers it as an integer 10, and then I can reassign the value for test. As you can see from the arrow, I am typing test equal to 20, and then I am assigning the value 20, and it immediately prints it as integer. Now you can see that I'm creating another variable of string type called myVar, and the initial value is skill speed. You can easily reassign this to something like welcome to skill speed. This is possible because it is a mutable variable which is defined by the keyword var. The next type of variable is called an immutable variable. As the name suggests, the value of an immutable variable cannot be reassigned. You create an immutable variable by mentioning the keyword val. As you can see, I'm typing here val test equals to 10, which creates an integer called 10 for the variable test. But when you try to reassign the value to test by typing test equal to 20, you can clearly see that there is an error coming up saying that reassignment to val. So this proves that the immutable variable which is created using the val keyword cannot be reassigned. Now as I was discussing before, Scala is very good at type inference. When you assign an initial value to a variable, the Scala compiler can figure out the type of the variable. Now in this example, I'm simply typing var, my var equals to welcome to skill speed, and it automatically identifies it as a string. But when I say my var equal to 10, it says that I cannot change the value of my var from skill speed to 10 because my var has been declared as a string. Now you cannot change it to an integer. So that means Scala is a statically typed language. Even though Scala can automatically infer the data type of a variable, once it infers, throughout the life of the program, the data type remains the same. That is a typical property of statically typed languages. Now let's have a look at assigning a block expression. Now if you are familiar with languages such as Java or C++, a code of block is represented by a curly braces. Now in Scala, when you type a curly braces and type some expression within that, that is called a block expression. Now in the example, you can see that I'm declaring a variable called add, and within the curly braces I'm typing val a equal to 10, val b equal to 20, a plus b. Now if you hit enter, you can see that the result is 30. This is because the value of a block expression is always calculated based on the last expression. Now in this example, the last expression is a plus b and the value becomes 30. If the last expression was something like print a name, then the result will be the name. Now another important principle in Scala language is called lazy values. Now lazy values help us to delay the initialization of a variable till it is accessed for the first time. For example, if you look at the example that I'm typing here, you can see that I'm declaring a variable called x, var x, and then I have a block expression where I'm having a print statement, I am not lazy, and then 15. So when I hit enter, since it is a block expression, what happens is that it prints x as integer and then I am not lazy. Now the same expression, you can add the keyword called lazy and then initialize it. So as you can see here, you are saying lazy val y equals to print I am lazy x plus 1. When you hit enter, you can see that nothing has happened. Since you have used the keyword lazy, the initialization of the variable has been delayed. But after that, when I type y, I am accessing the variable and then the variable will be initialized, thus printing I am lazy and 16. This is particularly useful in cases of frameworks such as Spark. When you are dealing with big data, you don't want unwanted initialization of variables. A variable may hold terabytes of data. You don't want that entire data to be present in memory unless you want to access that variable. Now, like I explained, lazy values are very useful for delaying costly initialization instructions. Lazy values don't give error on initialization, whereas no lazy values do give error. Now let's have a look at the control structures in Scala. Now control structures controls the flow of execution, and most of you could be familiar with the control structures in other programming languages such as C and Java. Now some of the most common control structures are if else, while, do while, and for. Now the control structures typically allows us to break a flow and control the flow. So you can start a flow and give a condition and then based on the result execute individual tasks. So in order to understand this, let's have a look at the first control structure, which is the if-else loop. Now, when you want to create an if-else loop, then first you will have an if statement, then you can have an optional else statement. Now, the if-else syntax is very similar to your Java or C++ if-else code. In Scala, if-else has a value of the expression following it. And another important point is that semicolons are optional in Scala. So to give you an example, here on the terminal I have typed val x equal to -10. Then I'm creating another variable called s, and then I'm applying a control structure wherein I'm saying if x is greater than 0, positive, else negative. And when I hit enter and then type s, you can easily see that it will go through the control structure and the value of s is negative since -10 is less than 0. So this is a pretty simple if-else loop. Now, if-else loops typically evaluate a condition, and based on a true or false, it can take an action or an alternate action. So the next control structure is called a while loop. Now, a while loop is typically used if you want to repeatedly perform an action. So here I have given an example. I am initializing a variable called x into 5 by typing var x equal to 5. Then I am opening a while loop where I am giving a condition x is less than 10. Then I am printing x and then incrementing it. So this means x keeps on incrementing from 5 to 10, and once it crosses 10, then the while condition will become false and it will get out of the loop. So it will print the values from 5 to 9. Now you can also see another example where again I'm initializing x equal to 5, and then I'm saying while x is less than 10, I'm printing x and then I'm typing x plus plus. Now in this case it throws an error because Scala doesn't support the plus plus variable or the variable plus plus formats. We have to use I plus equals to 1 or I equal to I plus 1 expressions. This should be noted by people who are coming from Java background because this is the way typically you write it in other programming languages. Now the next type of control structure is called a do-while loop. Now this is very similar to a while loop, but in this case, except the condition that a do-while loop is guaranteed to execute at least one time, and the condition is evaluated towards the end of the loop. So I have given an example for a do-while loop wherein I'm creating a variable called x var x equal to 5, and then I'm saying do x equal to x plus 1, print the value of x is increment x, and then I'm saying while x less than 10. So basically the condition here is that as long as x is less than 10, and then it is gonna enter the loop, and then initially the value is 5, it's gonna increment and print the value. So as it executes, you can see that it prints from 6 to 10. Now the last control structure which we have to be aware of is the famous for loop. Now a for loop can execute a block of code for a specified number of times. Now Scala doesn't have for initialize test update syntax. Now in order to explain this, I have taken two examples. So one is for loop 2 versus for loop until. Now you can use either the keyword to or until when creating a range object. Now the difference is that the to includes the last value whereas until leaves out of it. So in the first example, I'm creating a for loop where I'm saying for x 1 to 6 print the value of x is increment x. Now this will print all the values including 6 because this is a for loop too. On the other hand, you can also write the same expression like for x 1 until 6, which will print 1 to 5 excluding 6. So to wrap up in this particular lesson, we have learned about the installation of Scala, the data types, variables, lazy values, and the control structures in Scala. That's all for this lesson.
If you have any questions, please do not hesitate to raise a support ticket. Thank you.